I welcome you all back to this lesson, and we are going to talk about integration. To be specific, we'll be talking about substitution method. This is a method which we want to look at. I'm going to be very brief so that each and every person can understand how to integrate by using substitution method. So whenever you are dealing with integration, we've got chain loop, product loop, quotient loop. Those ones are not supposed to be used under integration. You are not supposed to use those ones as the main way of integrating a function. They are not supposed to be used. But along the way, we get to use them, especially the formula method of differentiation. So in this case, how can you know that in this question you are supposed to use substitution method or integration by parts? So I'm talking about substitution method. So my key interest is on substitution method. So how can you know that you are supposed to use substitution method in this question? So what you need to know is that you need to look at the two expressions which are given. So you are given this expression and this other expression. So you ask yourself, which one can you differentiate to give you a similar expression that will look like the other one? So if you differentiate this one, you know that differentiating we say -1, which means we're just going to have x if we differentiate this. But if we differentiate this one, which is down, we are going to have x squared, 3x squared, which means it is this expression which is down that we get to differentiate to get the other one. So I'm going to let this, I'm going to say, this is the first thing you need to do. Let u represent 1 plus x cubed. This is what you're going to do. After you do this, then you differentiate. You are differentiating u with respect to x. So this is the same as du dx, which is equal to, this is what you're doing. So you know that we don't differentiate a constant number, we leave it. If we differentiate that, that is 3x squared. I believe we all know what it means to differentiate. You multiply 3 times 1, then 3 minus 1. That's the reason why I've come up with this. We know how to differentiate. This is a fraction. After you reach here, your main aim is to find the value of this one, the dx. So you say over 1 here, then you cross multiply. So 1 times du times this one, it is du. So you are going to have something that will be like this. 3x squared dx is equal to du, like this. You want to find dy. So you divide both sides by this, 3x squared over 3x squared. Have you seen? So this and that will cancel out. What you are going to remain with, this is what you are going to remain with. So I'm going to say dx, you are going to remain with the dx is equal to du over what? X is equal to du over 3x squared. This is what you are going to have. I don't know if you've understood this part. After reaching this step, you go back to your original equation. You go back to your what? To your original equation. So you want to answer this question. This is the question. Hope you've seen this answer. So this is the question that we want to answer. So how can you answer this? You say, okay, you are having something like this. This is what you are given to answer. So I'm going to do this. This is what I'm given to answer. What am I given? I'm given to answer that x squared over 1 plus x cubed dx is equal to, so the answer, you write the integral like this. Then you know that x squared, you write it like this, x. So let me do this. So you do this x squared over, have you seen this one, 1 plus x cubed? It was given there. It is what? U. So you put your u there. Then your dx. Do you know your dx? We've just solved. This is our what? This is our dx. Have you seen? So you write it there. You say, you do this, you say du over 3x squared. Then you do that. This is what you need to do. Have you seen the way I've done that? I've just replaced, or rather substituted. This is what we call substitution method, because you are just substituting. So you substitute. After you do that, you say this is now equal to, this is equal to what? So you know that this u, which is here. So what you are going to do is this. You need now to be very careful on this. Have you seen this x? And this x will be cancelled. Have you seen that x and that x will be cancelled? The u here and the u there, don't cancel them. Don't make a mistake of cancelling that. Those are mistakes you need to avoid. So let's make sure we avoid such mistakes. So you're going to have something that will be like this. This is equal to, so integral like this, you write the integral. Here you've just remained with du over, we've remained with what? A 3 here times u, so 3u. Have you seen? This is what we've just remained with. I don't know if you are able to follow. This is what you've remained with. So this is the same as. So I just want to make things very simple to you. This is just the same as like this. This is the same as the integral. I put the integral like this. So I write the integral there. So after writing the integral there, then this is what? 1 over 3u. Then the du goes there. Have you seen? This is just one and the same. I've just separated the du here. So the du should go there. After I do this, then this part here, the u should remain alone here. Have you seen? The u should remain alone, this part. So it should be, this is now equal to 1 over 3 goes outside. Then I say integral. Integral of what? I've got 1 over what? Over u. Such that if you multiply these two, you're going to have something which is there. Then you put your du there. Have you seen what I've remained with? So this is what you need to do. After you do this, then you now know this. We all know this. This is what you need to know. So if you didn't know this part, make sure you understand it. The integral. So if you want to integrate 1 over u, the answer is what? Ln u. So the integral of 1 over u is ln u. Even if you've got the integral of 1 over x, the answer is ln x. This is what you need to understand. So this is ln x, this is ln u. These are what you need to understand. So this part here, you are able to differentiate the part which is here. You are able to differentiate the part which is here. So finally, you've got your answer which will look like this. So your answer will be in this format. So your answer will be equal to 1 over 3. Then you know that integral of 1 over u, it is ln u. So you put your ln u like this. Then you say plus what? We always include a c. Hope you haven't forgotten this. Have you seen? Like this. The c is just part of the formula. So you are not supposed to put the u which is here. You write the original expression. Do you remember the original expression of u that we had to equate? It is here. So u is what? You go back to that. What is your u? U is there. Have you seen? So just like that, you are done. So you just say now final answer is now equal to 1 over 3 ln u. You know u is 1 plus x cubed like this. Then you say plus c. So meaning that this is your final answer. This is your final answer whenever you are told to. Have you seen? This is equal to 1 over 3 ln 1 plus x cubed plus x cubed cross plus c. C should be put there to show that you're dealing with the integrals without the limits. After you reach there, have you seen? So what the answer which I've just answered, if I'm told to integrate this is the equation I'm told. I was integrating that. What answer have I found? So the answer which I've found, so integrating that, what is our answer? Our answer, I've just found the answer. So the answer was equal to what? What was our answer? Our answer was equal to 1 over 3 ln open bracket 1 plus x cubed cross plus c. This is your answer. So this is how you need to answer that. These are procedures that you need to do, get, and understand. The same way I'm answering this is the same way you are supposed to answer you too. So to give you a different question that is not related to this, let me give you another question where you are told to integrate. So questions in an exam, they will just tell you integrate. They won't tell you that use substitution by use substitution method or integration by parts. They will just tell you integrate. So it's you now to know that whenever, if you differentiate one expression, if it is able to give you the other one, which means that you can use substitution. So this is substitution. I want to make it simple to you so that you understand each and every concept that I'm illustrating with you. So now let me give you another example. Let us discuss through this example. So we are still under substitution method. Let us go through this other example. How can you answer this? So this is another question that we are having. This is another question. What if you are given a question like this? They will just tell you integrate. Integrate what? This is the question. Integrate x open bracket 1 minus x squared dx. You are given something which is like this. How can you integrate this? What are some of the things which are supposed to be done? What are you supposed to do? Have you seen integral? This is integral x open bracket 1 minus x squared cross dx. How can you integrate that? So if you saw how I was answering the first example, you can try and work out this. Let's see how you are going to answer it using the knowledge that I've shared with you. So how can you go about this? So what you need to do, I'm going to make it simple to you. So pause the video, then continue and see if the answer is going to be the same. So what you need to do, you check. You've got this thing which is in the brackets and this thing which is outside. So which one between the two can you differentiate to have a similar expression like the other one? It is this one. This is having power 2. If you differentiate something that is having power 2, it becomes power 1. So this one is having power 1. You know that, okay, somewhere, somehow, these two are going to cancel out. This is what you need to do. This is what you need to get and understand. So you say let. So I'm going to write it here. You say let. You say let u be equal to x minus 1 minus x squared, like that. So differentiate that. You are differentiating what? Du. So what you are differentiating is this. You are differentiating du with respect to x. So du dx, which is equal to that one, you just get negative 2x. If you differentiate, you know that you cannot differentiate a constant. You put 1 here, you cross multiply. You need to have dx there. So this one times that, you're going to have negative 2x dx is equal to u du. You divide both sides by negative 2x. You divide both sides by negative 2x. This part and this part cancel out. What you're going to have is dx is equal to du over negative 2x. This part very important. You need to make sure that you do that. Exactly what I'm doing. This is how you also need to do. Then you replace, you go back to your question, you replace. So this is, you do this, x maintains, open bracket, here there is a u here. You put u like that. So you just do what? You just replace. This is a matter of replacing. So you just replace there. What are you going to have? That part. On that part, what are you going to have? So what you're going to have is that after you replace here, you remain with this is u dx. This one. This is what? So what you have there, this is du over negative 2x. You've got something like this. This is what you have. There is x. So if you continue with this, where you are going to say this is now equal to this x and that x will cancel out. Have you seen? The x there and that x will do what? Will cancel out. So if these two cancel out, what you are going to remain with will be something that will look like this. So what you remain with, you are going to have a u there, then over what? Negative 2, then du. The du which is there, this is what you are going to have. So if you check properly what I did at first. So what I did at first, if you check properly, if you look at something which is like this, if you look at this expression, the way this expression is. So what you need to do now is that you now look at this part. The concentration now should be on this part now. So this part, your concentration is now on this part. How can you integrate something that is like this? How can you integrate something that is like this? How can you integrate it? How can you integrate something that is like this? So integrating something that is like this, if we are taught to integrate this, have you seen the way it is like this? U over negative 2. So if we are taught to integrate this, the way we used to integrate during our secondary school level, we used to do that. Here we say there is a 1 there, you say plus 1. Have you seen? You say plus 1. Then the same power 2 comes down like that. So you are going to have u squared over here negative 4. Have you seen? You are going to have what? Negative 4. So this is how we get to integrate that part. This is how you need to integrate it. Have you seen? This is how you need to do it to integrate. So I'm just showing you how you can integrate this, how you can work out this. Have you seen? This is what you are going to have. This is what you are going to have. Something like this. So you write this now there. So I'm just showing you how we used to integrate. Hope you haven't lost me. Hope we are still together. We are moving on the same page. So I feel someone is behind on this. Let me repeat what I said. During our secondary school level, if you are given an expression like y is equal to x squared plus 1, have you seen? And you are taught to integrate this. The way we used to integrate, just say 2 there plus 1 over the same power, 2 plus 1 comes here. Then plus, if a number is like this is the same as x power 0 plus 1 over 0 plus 1, then you put a c. This is how we used to integrate during our secondary school level. So, hope this is what we used to do. So now I just differentiated the part which is here, this part which is there, this part. So it's not always that you need to do like the first example that I did. It's not always. So after you do this, this is the same as you are going to do this. This is equal to now. So this is equal to the answer that we got. What was the answer? So this is equal to, the answer was what, if you remember very well? The answer was like this, where we said that it was what? It was u squared negative 4. Then you put plus what? Plus c. This is what you're going to have. Then finally, your answer, what is your answer? The negative goes on top. So the negative will go on top. So what you're going to have is that you're going to have negative 1 over 4. Then just put the u there. U. What is your u? 1 minus x squared cross. Then you put a squared there. A squared which is there. Then you just put plus what? Plus c. So this is your what? This is your answer. This is how you need to integrate. Have you seen the same way I've answered? Some people will go this way, which is just one and the same. So I'm not trying to say answering like that it is long. No. Some people will do where there is u, we equated somewhere. Where is u? U is this part. So you are able to see the u there. So some people will go this way, which is just one and the same. I'm not discouraging it. Just one and the same. They will say 1 minus x squared cross, they put power 2 over negative 4, then plus c. So what I've said is that this is the same as, you can just put what is common on top. It's 1. Have you seen 1 is common? 1 here. There is a 1 which is there. So there is a 1 here. So just put this negative goes on top. Negative 1. The answer that I found at first, negative 1 over 4. Then open bracket. 1 minus x squared cross squared plus c. You need to put a c, just part of the formula. So this is how you need to do it. This is how you need to go about it. So this is what substitution method. This is how you need to answer that. Hope you've seen all the methods I've done. These are things that you need to get. These are things that you need to understand. So with the substitution method, I'm going to end with this. I'm going to give you what we call integrals of elementary functions, which you need to know. Some of you were surprised. The reason why I was saying that when you've got ln what is equal to that, how did I know? So those ones you just need to know them. You just need to understand them clearly. So let me continue. I give you those ones. You need to make sure that you understand them. So for those of you that could like to communicate with me, you want help in mathematics, this is my number. Just call me on this number. You WhatsApp me. It is better you get to WhatsApp me. It is very easy to communicate with me like that if you get to WhatsApp me. So this is what the line that you need to call. This is my line. You need to call me on this line. Okay, so let me now give you these functions. So I hope you've seen plus 260971 066747 0971 066747. So let me give you some of these things. Okay, let me try to help someone. So if you are given something like, if you are taught to integrate this, the integral, so I will start with this one. The integral of cos x, so cos x dx, there's no need of solving. Whenever you just see something like this, just remember me, no solving. The answer is what? Ln sin x plus c. Sin x plus c. This is sin x plus c. This is integral. So this is integral. This is the integral. So integrating that, the answer is that. What if you've got, you are told to integrate this? You are told to integrate sin x dx. How can you integrate this? The answer is negative cos x plus c. So these ones, you need to know them. You need to make sure that you understand them clearly. What if you are told to integrate something like this? So the integral of e power x, we'll be finding these things, e power x. This is e to the power x. then they've put dx. E power x dx is equal to, this one remains the same, plus c. It will just remain the same, nothing will change. Up e to the power x dx is equal to e power x plus c. Nothing will change, it will just remain the same. Then if you are given something like this, so these are just a few that I want you to know, that I want you to understand. What if you are given something like this? So if you are given something like, let's say integral of, that I'm running out of markers. So if you're, yeah, this is good. If you're given something like 1 over x dx, the one that I did, so I just said, what is the answer? Just put ln what? X plus c. This is what I answered. So if you're having 1 over u, this is ln u plus c. So these ones are constants. You need to know them, understand them clearly. So what if you've got something like this? So let me give you another one. What if you've got something that is like this something? So I've given you a main 1, 2, 3, 4. So let me also include, think something like this. Ax dx. What is the answer? What answer are you supposed to get? So it can be a to the power u. So it is ax over ln a. So this is ln a. Then you just put plus c. So these ones, you need to make sure that you know them, you understand them clearly. Make sure that you know them and understand them clearly. If you've got a book, make sure you write them down. You can be taught to work out something in that nature. So let me also give you the last two ones. So they're about 7. You need to make sure that you know them, understand them clearly. These ones are very simple now. What if you want to find the integral of 0 dx? The answer is just a c. This is 0. Integrating a 0. Have you seen? This is integral. This is not s. Integral like this. Then if you've got something like you are told to integrate x power n dx, what is the answer? What answer are you given there? So that is the one that we get to use, plus 1 over n plus 1 plus c. This is what we know. We all know this one. This one is known. Whenever we've got, maybe you've got 2x to the power 4, we just get to do this. This one is the same one that we used to use during our high school. This one is very simple. So these are what you need to get. This is what you need to know. So I'm going to end here. Hope you've seen how I've solved this. Hope you've seen how I've answered these ones. So let me just leave you with a question. Let me just leave you with a question that you need to try out. You see how best you can answer that question using the information that I've shared with you, using the information that I've given to you. How can you work out these? So these ones require a process. You don't need to just answer them like you are done. No. So make sure you take your time, understand them clearly, properly. So integrate. This is the question. Integrate. This is the question. You integrate. The first one that I'm going to give you is this one. Integral of x square root 1 plus x squared dx. I want you to integrate this one. I also want you to integrate this one here. So integrate this one. Sin x cos x dx. I want you to answer these two ones. Answer them and see how you can work them out, the answer that you are going to get. So let's see how we are going to answer these two. Let's see how we are going to form the answers. Thank you so much.